In this particular section, we're going to look at, once again, we're talking about independent and dependent events, but in this particular section, we're only going to focus on dependent events. So suppose I have 8 shirts in the closet, 4 blue and 4 green. I'll pull a random shirt from the closet and give it away. Then I'll pull a second shirt from the closet and give that one away also. I'll then pull a third shirt from the closet. Now the key phrases in this is, I give them away. What makes this a dependent event is I am not replacing them. I'm not putting them back in the closet so I can pull them again. Once I take them out the closet, I am not putting them back into the pile. And that's what makes it a dependent event. Why? Because when I pull the first one, I've now changed the probability of the other ones being chosen. Now, we'll take a look at it just a little bit more so you can get a little bit better understanding. All right, so I want to know what is the probability that I get a green shirt in the first event, the first time I pull a shirt, and then I get a blue shirt in the second event. So the second time I pulled it is going to be a blue shirt. And then the third time that I pull it is another green shirt. So I want to know what's the probability that the first time I go through, I pull a green shirt, then a blue shirt, and then a green shirt. So that's what we're going to try to figure out right now. All right, so once again, I'm just going to put the list here that I have. I have 4 blue shirts and 4 green shirts. So that's our list that we're going to look at. So because this is a dependent event, I can look at them. I can separate them, but I am going to have to be very careful here. So I have the probability of a green shirt times the probability of a blue shirt times the probability of a green shirt. So the probability of a green shirt, well, first of all, because this is the first event, you can count. I have 8 shirts to choose from, and 4 of them are green. So that's the probability that I will pull a green shirt on the first event. Now, because of that, we can go ahead and cross out a green because I no longer have that option. Now, what's the probability in the second event that I pull a blue shirt? Well, first off, what we're going to need to do is we're going to need to count how many total shirts do I have. And as you can see, I have 1, 2, 3, 4, 5, 6, 7. That's why this is a dependent event, because I no longer have 8 shirts. I have 1 less. So I'm now dealing with 7 total shirts. Well, how many of them are blue? Well, as you can see, I have 4 blue shirts. Now, what's the probability in the third event that I have a green shirt? Well, let's go back to our list. I no longer have a blue shirt, so that brings my total down to 6 now. And green, as you can see from the list, I have 3 of those. So I now have 4/8 times 4/7 times 3/6. And that answer, when you multiply it, will come out to be 1/7. So there's a 1 out of 7 chance that I will get a green shirt on the first pull, a blue shirt on the second pull, and a green shirt on the third pull. All right, this question right here, we're going to do it twice. And the first time we're going to go through is going to look exactly like the problem we just got through looking at. But the second time we go through it, you really have to pay attention to the question that I'm asking, because the way we're going to do it is completely different than the previous problem. So let's just now take a look, and here's the first question. So I want to know the probability that the first piece of fruit is an apple. So the probability that the first piece of fruit is an apple, and then the second piece is a peach. So once again, let me just write that down. I want my first event to be an apple, and the second event, messed that up right there, and I want my second event to be a peach. All right. So what you're going to look at is all right, we're going to take the probability of an apple times the probability of a peach. Well, here it is. We have how many total pieces of fruit? We have 12 total pieces, and 5 of them are apples. Now, please take this into consideration. After I take the fruit, I am eating it, so I am not putting it back into the basket. So because of that, this is a dependent event. So when I multiply, I know that when I'm looking at the peaches, I no longer have 12 pieces of fruit, but I now have 11. And I still have 7 peaches. So therefore, it would be 35 and 132. All right, we're going to look at the exact same problem. A basket contains 5 apples and 7 peaches. You select one piece of fruit. You're going to eat it, so that's going to make it a dependent situation. And I want to know the probability of an apple and a peach. Now, you might be asking yourself, okay, what's the difference between this problem and the last problem? Well, this problem, the last problem, let's look at the last problem. The last problem, I asked for the probability of the first event being an apple and the second event being a peach. So I wanted that order. I wanted to know, okay, the order is the first one being an apple and the second one being a peach. In this particular problem, I don't care about order. I don't care if you grab an apple first and a peach second, or grab a peach first and an apple second. That matters. So because I don't care about the order of things, this problem is going to change, and we need to make sure we're ready for it. So let's talk about it. So order doesn't matter in this problem. I just want, when I'm all said and done, I want to be able to have an apple and a peach. So let's look at how we would do this. So once again, I'm going to look at, okay, well, let's look at the first situation I could have in this. The first situation says, well, I could have in my first event, I want to have an apple. In the second event, I'm going to have a peach. So let's take a look at the first event. We did this problem in the last one. We said, all right, so probability of me having an apple, well, we know that there are 12 pieces. Give me a 5. So we said it was 5 out of 12. And we're going to multiply that times the second event, which we knew, once again, that I only have 11 pieces of fruit left, but I do have 7 peaches. And we talked about that. That was 35 over 132. Now let's take into consideration the second possibility that I can have. The second possibility is the first event, instead of an apple, it was a peach. And the second event suggests, well, if the first event was a peach, then the second one has to be an apple. This is the second possibility I could have had. Well, let's take a look. Well, in the first event, if it was a peach, I had 12 outcomes. And if it's a peach, then I had 7 out of 12 because there were 7 peaches, and this time I had 12 pieces of fruit. All right, I grab a peach, I ate it. Now, for the second event, I no longer have 12, I have 11 pieces of fruit. And how many apples do I have? Well, you guessed it, I have 5 apples. So, once again, 7 times 5 is 35, and 12 times 11 is 132. So what we're going to do in this situation is, because both events, both possibilities do exist, we're able to add these probabilities together. So we're going to add these probabilities together. To get my final probability, which is 70 over 132. So this is my final answer of grabbing a probability of grabbing an apple and a peach.